Alright, so here is a programming exercise called Baseball Game, and you are keeping the score for a baseball game with strange rules, and these rules have nothing to do with baseball, so this isn't really about baseball at all. This is just a game, and these are the rules of the game. You basically have a bunch of scores. Or let's see here, you have integers and operations. So if it's an integer, you just add that integer to the score. But if there is, or you record a new score. And then you can have these other operations where you can create a new score, which is the sum of the previous two scores, a new score which is double the previous score, and you can remove a score and return the sum of all the scores. Okay, so basically what we have is we have this list of operations, and we want to just loop through the operations. And so we're dealing with a number of different scores here, and so we're going to need to store all these scores in a list. And then so we're going to have to work with that list. And the only other thing with that, so we're going to be looping through the operations one by one, but the scores, scores can be added and they can also be subtracted. So we're going to need to have some other variable to keep track of the next index that we can add on to in the list of scores. And it feels a little clunky, but it will work. Now it is worth reading through everything here, and we have these constraints, and this is really useful. So it says that basically for anything that's not recording a new integer, all of these special operations are always going to be defined. And so we don't need to add in extra logic to verify that these moves are valid. We can just assume that they will be valid. Okay, so that's really nice to know for our programming, because that's one less thing we have to do. Okay, so let's write this out. Again, I will write this by hand because it helps me learn and I like it. Okay, so we're going to need to keep track of our scores. So this is going to start as an empty list. And then we're also going to need some index. I'll just use I. And this will be the index where we will put the next score in the list score. So here I equals 0 because the next score that goes in this list scores is going to go into index 0. Okay, so now let's start looping through. So for op in operations. Okay, so we have these things that can happen. We can have a plus, we can have a D, we can have a C, or we can have an integer. So the most straightforward way to go through this, in my opinion, is to just go through these three cases first, because these are very straightforward if clauses. So if this operation is equal to plus, then we do that. And then later on we will have separate if clauses for D, for C, and then the else will just be adding the integer. Because these are assumed to be valid moves. And so we can just assume, if else, we can just assume that's going to be an integer. Okay, so if we have plus, that means the new score is going to be the sum of the two previous scores. So scores, we're going to append a new element, and it's going to be the two previous scores. So I is always going to keep track of the index where we are putting the next score. So the next score is going to go in index I. And so if we're adding the previous two scores, those scores will have indices I minus 1 and I minus 2. So we're going to append scores I minus 1, and I'll write on the next line here plus scores I minus 2. Okay, and then because we have added a new element to scores, the index of the next where the next score will go has to increase by 1. So we will increase I by 1. Okay, and that's what we do if it's plus. Otherwise, if the operation is D, then we include a new score that is double the previous score. So scores dot append 2 times the previous scores, which will be scores I minus 1, since the new score will go into index I. And then because we've added a new element, we need to increase I by 1. Okay? Otherwise, if the operation is C, then we need to remove the previous score. And so there's a few ways you could do this. The easiest way, I think, is to use pop. And this will just remove the last element from this list. And then because the list is shorter by 1, the index of the next element has to decrease by 1. And then otherwise, we are guaranteed, because the inputs are guaranteed to be valid, the remaining case, this guarantees that the operation is going to be an integer, which means that the new score is going to be that integer. So we take scores and we append that integer, which is stored in op. Okay. And then we increase this index by 1 again. And then we just return the sum of this list. So that's what we do. It does feel a little clunky to have these I plus 1s and I minus 1s, but this is sort of how we have to do it because of the fact that we can be either appending or removing elements. And plus, this is, I don't know, this is straightforward enough of a code that it's fine. But yeah, that does feel a little unfortunate, but whatever, this will work. Okay, so now let's test it out. Scores, make a blank list, and this index is 0 for op and operations. I'm going to append scores I minus 1 plus scores I minus 2. And we're going to increase I by 1. Otherwise, ooh, I'm missing something here. We only want to do this if this operation is plus. You know, this, I still get thrown off by this whether it's a good convention to use like single quotes or double quotes. And even like in the problem statement, we see single quotes being used here, which is sort of why I defaulted to that. But then here they use double quotes. I don't know. It's fine. I don't know. It seems like even though the convention is to use double quotes, single quotes seems to make the code look neater, and it also seems to be the convention when you're referring to the names of columns of data frames, whether that be pandas data frames or PySpark data frames. But in any case, it has no impact on how the code will run, so we'll just not worry about it too much. Okay, so in D that means double, so we double the previous one. We have to increase index again. Otherwise, in the case of C, I don't even know what D and C, like D is for double, C is for could invalidate, I don't know. So if it's C, we're going to not OPO, but we're going to pop. And then we have to subtract 1. Okay. Then at the end, we return the sum of the scores. And let's submit this. And this did not work. What did I do wrong here? I am missing something. What happens if it's not one of these three? Okay. Now, of course, if we're not in any of these three cases, then we need to append the operation. We're going to add I plus 1. But something that I didn't catch before, well, actually, let's try this and see if this actually works. I don't think it's going to. Yes. Okay. You can't add integers and strings. So that means that scores must contain strings. Why does it contain strings? Well, when we included this operation, look at this example. The integers are stored as strings. So we need to convert this to, we need to convert the operation into an integer before running this code. So now let's do this. Okay, there we go. I don't like the fact that it's still showing. This just must not have refreshed because we got, it was accepted, like this does work. So that's a little annoying. But in any case, this is this works. So maybe if we hit run again. There we go. Okay. Yeah, it was just a visual thing. Okay. Yeah, so this is the solution for this exercise. It's really just an exercise in understanding the problem statement, instructions, setting it up, and running the code. So there you go.